Okay. So the first thing that we want to take a look at when we're doing things is if we look at this, and I can share this all with you. You're going to hear things about C1 to C2, C1, C2, C0, and what that is basically referring to is the intersection of the surfaces. So C0, like we've talked about once before, means it's just edge to edge. The two edges come into contact. So it could be an angle, it could be a 90 degrees. There's no smooth transition to it. Just think of it as there's a corner, there's an edge. You know, when you get into C1, it's basically you've got a few areas, but it's not all over the place. Sorry, C0, C1. When you start getting into C1, you start seeing radiuses everywhere. But you can also see where we talked about before, you know, when you just put in a fillet, there is that hard edge. So C1 is tangent. So all your surface connections are tangent. You're not really worrying about curvature or anything like that. When you get up into, you know, C1, C2, you start, you know, fixing some of the things, getting some curvature in there, but still some tangency. You know, same thing as it builds. But here you can see now that we're getting into C2 is that you can't really see an edge anywhere. You can't, everything has curvature continuous. Everything is smooth. It's very organic feel to it. And then C2, 0, you know, that's where you're kind of getting edges in the surface. They're still radiused. Everything is still very smooth, but you're going to start getting some, you know, tangent breaks in there. SolidWorks does C2, which is curvature continuous, but it does, well, it does C3 now, and we'll talk about what C1, 2, 3 is a little bit later. But it doesn't do it very well. Questions about this little charty chart? Okay. We've seen this before, just as a refresher. Kind of like what we just talked about. C0, positional, hard edge. C1, tangent. So picture a, you know, a proper radius between two surfaces. C2, it's basically a curve between two surfaces. And this is just another way that shows it. That might be a little bit easier to see. This is from Alias. Okay. So there, even though we saw the surfaces, everything there is controlled by the spline. So before we do that, let's dive into patch modeling. And when I open this up, you'll see exactly what I mean by patch modeling. Okay, so this is a concept handle. Basically, it was built in Alias by the designer because they wanted to get the overall form and feel. Then it was handed off to an engineer who cored it out and created the internals. And then they came back and said, okay, hey, we need to make this draftable. And we need to have a part line. Let me just go and insert something here. Insert reference geometry axis. Oh, wait, let me do it on. Excellent. Okay. So when they came and they said we need to do this on a part line, insert reference geometry plane. We'll put it right there. So you can kind of see that it splits. Now what I'm going to do is I'm going to show you a tool, and we'll get down into this later on during manufacturing when you guys are working on the rotational molded, or if you're working on something else. So they come back and they said, hey, that's where we want our part line. So I'm going to come up and I'm going to pull up the draft, and I'm going to say, hey, look, this is the part line. We want the part line to go up and down. So we're going to select that, and we want it to be 3 degrees. So basically what that means is everything that is green that is above has 3-degree draft. Everything below it that's red has 3-degree draft. Anything that is yellow, less than 3 degrees. But here you can see this red means there's an undercut. This red means there's an undercut, but that's fine. So the challenge is now to come in and fix things. So the first thing they wanted me to do before they said fix the draft was, you can see here something that everybody's experienced is just dropping in radiuses. It comes to a weird end down here. It's a whole bunch of weird stuff here. And all of this is what's causing some of that problem with an undercut. Now, as I look at this, I say to myself, okay, well, it's not, this is kind of complex geometry. You know, I don't want to have to try to reduplicate this to match it. So I don't want to rebuild all the surfaces, go back and trim them and do all that. So having a plan of attack, what can I do? So the first thing I wanted to do was clean up this area so that it's clean, it's manufacturable in that. So that was my first plan before they said, oh, great job, can you make it draftable? So let's first, we're going to come in here, and basically you can see the model prior to these radiuses. So I was able to pull out some of the garbage. Basically what I ended up doing is trimming things back. Let me just go back up here a little bit. Starting to trim things back, deleting the faces so that I can start getting things to work with. So think about it like this. If you've got a hole in a wall or your car or something, you don't always just try to fix that one spot. Sometimes you cut around it so that you get cleaner situations. So keep trimming, deleting, pulling things away to try to clean it up. You can see here I've added in a radius via the surface because I have to transition there. I took this area and I patched it and I filled that in. Then I started patching in the surface fill. Now at the same time, so now you can see what happened is I took out what was one surface. I added in 1, 2, 3, 4, 5, 6 surfaces. to clean that all up. So it's called patch modeling. I'm not necessarily rebuilding a whole lot of things, but I'm also modeling edge to edge. So I'm not overbuilding and then trimming back. I'm using existing edges to sweep the surfaces. So I'm not trimming anything. When I do that, that means I have to pay very close attention to how clean this surface is, how clean this surface is, and of that nature. So the next was for them to come back and say, that looks beautiful, but hey, can you draft it now? And you can still see where it's garbage. But what I need to do is I need to split the model in two so that I can deal with along the part edge here. So we're going to split the model and hide the bottom half. Hold on one second. Okay, just wait a second. So this is where we come back with a plan of attack. You know, looking at this and saying, okay, the problem is that at this point, the curve is not draftable. So what am I going to do? I'm going to start deleting faces, putting faces back in, using splines to control the surface. So if I come in here, and you can see where I start pulling out faces. But then I'm dumping surfaces back in. And before I show you that, if I come in and I do the draft analysis, you can see now where that was a weird line, I've got it in there. The way I was able to do that, and I believe I showed you guys, everybody, this. So create a spline, straight line, but I had to make it so that it was tangent to this top surface. But down on the bottom, I don't need it tangent, I just need it positioned. But then what I did is I went in and dimensioned it. Because if you recall, and we'll get into this more, that first dot, that diamond, means tangency. The arrow means curvature. So what I can do is I can come in and say, oh, so I know that 3 degrees is what I need. So I make this and I say go 3 degrees. Now, keeping in mind when I mirror this part, there's going to be kind of a point between the two, because the top one's going to go up 3 degrees, the bottom one's going to go 3 degrees. It can't be a perfect circle. That's the reality of doing parts for manufacturing. You know, as designers, where this becomes important is, you know, if it's a looks like model, but it's not going to production or anything like that, you can get away with not putting draft in. Unless it's one of those things where draft is extremely important because it affects the visual a lot. So, for example, if I need 10-degree draft on here, you can see how that's going to change that wall. It's not curved anymore. It's almost straight. So that's where you want to be careful, because what happens is by not doing this is someone gets the model and says, well, that's not what it looked like. I loved what it looked like or felt. But basically what I did is continue to do that all the way around, basically filling in the gaps, patching things up. So if I scroll, And this, so if I scroll all the way down here, you can see when I had to add draft, I had to blow away everything I did in this corner and redo it. But if I come back, you can see here I've got good clean 3 degrees all the way around. Talking with the engineer, we were fine with this being 1 degree. So I change it back and I go 1 degree. Now, very tedious. Surfacing is much more tedious than solid modeling. It can be frustrating, especially in SolidWorks where you do have to use planes a lot. I'll show you when you should use 3D splines and when you shouldn't, because that can make things a lot easier and quicker. But going in and doing this to get your radiuses right, or to add in a detail like this where you would cut something out and fill it back in with the surfaces, that's kind of what's referred to as patch modeling. Is there questions about that? Does it kind of make sense on what's happening and what's being done? Okay.
Wait, so this can only be done on like a solid body, right?
No. So you could have a single surface and then put a detail into that singular surface. Exact same approach. I just happen to be doing it on here. So like I could come in and say, okay, well, I want to modify this. So I'm going to come in and, oh man, there we go. I'm going to delete that. And I'm going to add a plane here. And what I want to do is I want to modify this. So I'm going to come in on here. I'm going to draw a sketch. So I've cut out my center, and now I'm going to patch it back up. So what I'm going to do is I'm going to come in here, make a spline, make sure I've got it on the right one. I'm going to connect to there. I want that edge on there, so just ignore this. Insert curve, split line, that, with that. Oh, hold on. What I'm doing is, in order to ensure that my curve fixes to that surface, I want to have some point that I can get it affixed to or make it tangent. So what I'm doing is I'm just adding that edge so I know where that is and I can snap to it. So what I'm going to do now is I'll take this point. We'll edit this. Come on. So let's say that's what I want, and I just want to be able to have something different than that flat surface that it was. So what I can now do, again, patch modeling, I'm doing edge to edge. I'm not overbuilding, I'm not trimming anything. I'm going to come in and do a boundary surface so that I can loft amongst multiple sections. Come on. Since there's multiple edges, I have to use my selection manager. Same as on the bottom, so I'm right-clicking, selection manager. So now I've got that extra little dip in there. So imagine if that was just a surface, and that's what I wanted to put in. Perfectly fine as well. Okay, let me, other questions about this? Awesome. And as we go, sorry, what was that?
I said all good.
Okay. And as we get further down, there will be specific examples that we do. Right now, it's more about, here's the overview of what it is. So let me not save that. Let me come back here. This is going to be somewhat of a edge to edge as well as an overbuild. And I'm pretty sure I showed this to you. This will be one of the assignments that's kind of like a speed form. So if we look at this, you can see here where I started off overbuilding things and then trimming everything back, offsetting surfaces, trimming things back again. So again, I'm offsetting, trimming. Now one of the things is by doing this, I've also made it modifiable so that if I take this line, I can move this line whoops, got to exit the sketch, and it updates. So that's kind of where we talked about before about, you know, overbuilding things, trimming in the back. If we drop down here and we go a little bit further, you can see I'm starting to create the layers upon layers upon layers. And if we go back to this, so you can see, no, that's not what I want. This is all being built off of a concept sketch. And then as we get all the way down, oops, I went too far down. Come on. You can see that what I've started to do is I've started to model edge to edge. There's no trimming back of this. So, and then from there, I took this edge, modeled along here and here. So that's, by definition, the edge to edge. But for the bulk of the forms, I'm doing overbuild. Now, let's see if we go all the way down. Oh, we don't need to see the shell because that's for 3D printing. You know, again, built it in half so it could be mirrored over. Now let's see how good my model is. Do we think it's going to blow up? What do we think? Blow up? Yes or no?
No.
No? Now you got more confidence than me. So we're going to extend that. We'll extend that. we'll drop that down. Because for whatever reason, I've decided I want it to be bigger.
Oh, you're doing a lot to it. Never mind. I'm less helpful.
Nope, I blew up.
So then you just scrap it, right? You just throw away your computer.
Ooh, even then I still blew up. So obviously there, I didn't build it as clean as I wanted to. This was a demo model, so I was probably going faster than I should. But there is a difference between how long it takes you to build the model. If I've got clients, you know, as you guys are building things, if you think you're going to have to change it down the road, is it easier to spend some time up front? Or if it's just, here's the model, we're not going to change it, well then, down and dirty. That other model that I showed you, that handle, I've got the first half completed. That is 10 hours in to go through and methodically refine it. So let's get rid of that and let's not save. Okay, so I do have a, oh, whoops, where'd that folder go? I'm going to email this out. We do have a couple really, really chintzy stuff from a long time ago. Not mine, but you'll see hybrid modeling. So if you ever, so Matt Lombard he's got a book called SolidWorks Bible. But if you look him up, he does quite a bit of surface modeling. His background is engineering, but he works a lot with industrial designers, therefore he has an understanding of it. So I'll share this. It's just a good little read on what is hybrid modeling, you know, some of the different types in that. Ignore the graphical layout and just pay attention to the text. So I'll send that to you after class. Okay. Before I know it's early. Before I dive into splines, do you want to take a quick break, or you want me to dive into splines, and then before I have you do the assignment, take a break? The latter. Before the assignment. Okay, good. So let me open up SolidWorks here. I'm going to start a new one. Okay, so I put my glasses down and I don't see them anymore. There they are. So we're going to start with a sketch. Now, there are two types of splines, or different ways of using it. And you can see here, we've got spline, style spline, equation-driven spline, which I don't touch. I'm sure it's really neat, but I'm not about to drive my splines through mathematical data. That's beyond me. So what we want to do is I'm going to start with showing the first spline, and we'll talk about that. So this is the spline that a lot of us have seen. I'm going to make a point there, a point here. So we've got a perfectly straight line. And the way I control this is by using the triangle to get the angle that I want, the arrow to get the curvature, of it, or the circle on the end that allows me to move everything at once. Same as the back end. Now, I've got 2 points, 1 point here, 1 point here. That means that I can affect what happens up to the midpoint here, up to there, but I can't really do anything more than what you see as a capability here. Now, as we build splines and curves, one of the things I want you guys to get very used to as you play with it is click on it, right click, and come down to Show Curvature Combs. This is going to let me actually turn that density down. So I can change how high that goes. I can also change how many are in there. So what this does is it shows the inflection. So right now we know that there is no dips in this curve. It is all going in this direction. And what it also helps us to do is to understand where the flat areas are and where the curvature is. Because if I come in, how are you guys seeing the yellow on my screen?
It's a little tough.
Okay, I'll see if I can figure out how to change that in the future. There, that should work better if I highlight the line. So you can see at the back end, if we mean the back end, I'm talking about the right side, that it's somewhat flatter and then becomes more curved or a greater curve on the left-hand side. I can get that even more so. We'll get it down to... So now you can see that for the most part, slight curve, but pretty flat with a very slow transition to a curve and then to a drastic one. Now, we talked about this once before. What these curvature combs do is also tell you how much of a highlight it's going to have or how fast it's going to go. If you guys ever take a shiny object and you rotate it, you know, at the same pace, you'll sometimes see that the highlight starts slow, and then as you wrap it around a radius, it goes a little bit quicker. So we want to make sure we have this. Now, the next reason we want to make sure that we have our curvature combs on, or what it communicates, is that right here, there's no what's referred to as inflections. But if I come like this, now, even though it's very noticeable on this, what it's basically saying is there's a convex and concave curve. So at the back end, it swoops in, creates a pool or a puddle, and then it comes back up. That might be hard to see sometimes without having the curvature combs on, because for all intents and purposes, this looks pretty good. But if I come in here and let me really increase it here, you can see more so now at the back end that it has an inflection. So what that will do is it'll give you either a highlight you didn't want or a low spot, something. Having the curvature combs on, really paying attention to your curves, you know, it's one of those things where if I do a marker rendering and my drawing is crap, the marker rendering is going to look like crap. So here we're doing the drawing, we're making sure those curves look good. Now, let's say I want to have a little bit more control in the middle here. what you can do is you can draw a spline that has multiple points in it. So there's one point, there's the other point, and there's the next point. And you can see how it curved through it. What that allows me to do is, before I do that, I have a little bit more flexibility. And you can see I can't do that with this curve. I can have an S shape, I can have an arc. I can't get that, we'll call it an M for here. What I can also do though is I can play with the lengths, so all the different things I can play with. But now you'll see, because as you guys are going to play with these, they can be somewhat hard to manage. It varies. Also, if I come back here and I put on my curvature combs, you can clearly see where the inflections are. But even if I get rid of those inflections, you can see now where, let's say I don't want that inflection there, but I want that sharper there. I've got to come in and play with it, but that's not what I want. So, you know, how am I going to play with that? So you can kind of see it starts getting hard to manage it and to make it easier to use. So questions about those curves? Okay, so the next that we'll talk about is if you click on the spline tool, it comes to what's known as style spline. I don't know why they call it style spline. Some softwares call it CVs. And what we're going to do is this allows us to make a style line using points. So we don't control it through these handles. We're going to control it through the points. So you can see I don't have any of this on here. What I do have is a couple points. Now, this curve, this line, is like this one here. I can't really do, I can get my S, I can get my arc, but I'm not able to adjust it in the middle like that. One thing, so if I want to have more freedom, I have to add more points. Can I do that in here? So what you can do, okay, so they call them control vertex. Much like here, if I want to add one of these points, I can click on the line, right click, and I can go insert spline point. So now I've added one without having to redraw it. I can do the same here. Oh. Sorry, I added it on the line like I did up here, but you have to add it up onto here. So now you can see I have the same control as I did this with the 2. For me though, I find that it's much easier for me to control these ones than this one. Because if I go and let's add in our curvature combs, I'm not getting those weird inflections. I find it much simpler, and I also find that I get a cleaner line. I don't get stuff like this where I don't want it. That's me, that's my knowledge of using the splines. Now, we've talked about when you're drawing the spline, having C1, so C0 is it just touches. C1 is that two lines are tangent. C2 is that they're tangent and curvature to each other. So here, we've got tangent, curvature control. In order to achieve that, let me just come in here. Right here, if we match this with this dot is equivalent to having the tangent control. So the best I can ever achieve with this line is tangency, because I don't have the second control point that controls curvature. So if I want to get curvature on both sides, what I would need to do is come in, you know what, it's just easier for me to draw another one. And what I do is, here's the start of my line, here's my tangent control, here's my curvature control, tangent control, end of line. Does that make sense? It's a little bit more manual, but again, I feel like manual is better for me because I'm able to have some more control. I'm not saying what one to use. I'm telling you what one I prefer. I will tell you that it is better to try to use the least amount of points to get what you want, because too many, one, it's more mathematically complex, because what's going on behind the scenes is that the software is running mathematical equations to understand this spline. More complex curves, more complex surfaces. More complex surfaces means larger file sizes. It means slower run times for the computer in that. So if I want to have even more control, like we just talked about, I'm going to come in, insert one more point. And just like here where we had this extra point, this point is the equivalent of this point here. Because again, tangent, curvature, extra point. I can get a smoother transition, a little bit more control and guidance. Okay. What I'm going to do here is just go and quickly show you those curves and those tangent lines. Questions? Any?
Yeah, Travis, I know you've probably talked about this, but like for the bottom line, how do you get those curve columns to show?
Yep. So, two different ways. I can come on here, highlight the line, right click, and it says show curvature combs.
All right.
And then Benji, so it's like using the pen tool in Illustrator, but for 3 dimensions. Yes, except for the fact that these are only 2-dimensional lines. They are all on a singular plane. I cannot take these and modify them. It's all on a singular plane. Does that make sense? If you want to have a spline in 3 dimensions, X, Y, Z, that's where we have to use a 3D sketch. And then you would use 3D splines. We'll get into those later. No, this is only a 2D sketch. because I put it onto one plane. So these are all on a singular plane. Can you convert the two different styles of splines between each other? Do you mean, can I... Are you saying, can I take this and convert it into one with the points, Dominic? I don't know. Oh yeah, convert to style spline, right there. And then I should be able to do it vice versa. But, yep.
So right now we're just using the like yellow lines to figure out where undercuts are and stuff. But to actually make this into a surface, we'd have to use an operation like loft or something.
Correct. Loft, extrude, something of that nature. So one thing, let me just go back. So watch how easy it is for me to adjust this line. So I can kind of control it. I think I control it pretty well, you know. But now let's come in. We're going to put back on. No, come on. Not letting, there we go, we're just going to go up here. So you can also come up here to show curvature combs. So what I'm going to try to do now is adjust it. But you see how by adjusting this, basically what it does is it says, hey, you're not going to move this point or this point. So these points won't move, which then makes it, in my mind, a little bit harder. So if, like you can kind of see here, well, I don't want there to be any inflection, so I got to adjust that. And then I got to come and see if I can adjust that. But then start looking at that. You see the weird dips and wobbles and dips and wobbles? That's going to show up in your surfaces. That's why more points is not necessarily better. And then just to kind of show what Benji was talking about, I'm going to exit out of the sketch. And for this, we're just going to say, let's do an extruded surface. And that's what's going to give me my surface. Okay, so let's come back to this sketch. You know what? Let's do a new sketch. So what I'm going to do is I'm going to show one point, one line there, one line here. And what we're going to do is do a transition curve. So I want to bridge a line from here to here. Now, what I'm going to do is I don't want these to modify, so I'm just going to take them. I'm going to anchor them so that they can't move. You can see now everything's locked in. And I'm going to build a line between the two. So straight line, C0 has a hard point. we'll come in, we'll grab this, Control, left click here, because we're saying what do we want the relationship to be between those two. What I've got is I'm just going to simply make a tangent. So you can kind of see all that's locked in is the triangle for tangency, the angle. Now, if I come in and I come over here, we're going to say let's make it curvature. No, I'm not going to touch curve. Now, we're going to come in. Show curvature. Now, here's the thing. They're just tangent. That's why it's not a beautifully clean surface or curved smooth between them. If I extrude this, so it looks like when you read that, it looks like, oh, hey, maybe there's a dip in it. So if I come in and I extrude this, oh, I got to get out of my sketch first. If you all remember, oh, that doesn't actually look like it's tangent. So let's come up. We're going to go evaluate line deviation. Yeah. So it is tangent. So there's zero deviation between the two. So, but there's not curvature continuous. So same as here. 0, 0, 0. Come in, let's look at rate of curvature. It's clean and smooth. It's all the same rate of curvature. Nothing changes. Look at the zebra stripes. You can see that it transitions smoothly. There's no jogs in the curves. If there was a jog, that would mean it's not tangent. Let's turn that off. We'll turn that off. But now let's come back and adjust this. So now you can see by changing it to curvature, this line follows this line's curve for a little bit. So did everybody see how that's smoothed out? We'll come over here, we'll do the same thing. Now, if I extrude it, there should still be no deviation between the two. Or it's simply not going to do it for me. You can see that there's no deviation. Now, what you can see, and we didn't do it drastically, are you guys able to see that there's a little bit of a red in there? What it's doing is, if you look at my numbers, the rate of curvature and the radius are all 147, and then it becomes larger up here, but then it starts to flatten out. And that's what it's showing you in there. But if we come back and we go to zebra stripes, everything is still nice and smooth. So let me just come back here because I want to show you again what C0, or not C0, yeah, C0. Now, If we go deviation analysis, you can see that there's an average deviation because we know that it's C0. All we're saying for it to do is just touch. Edge to edge, just touch. What that also means is if you look at the zebra stripes, they're not smooth. You can see the gap. Same as if we go to curvature. Now you can really see the transition in the curve. If I come back to my sketch, without my curvature combs on, that looks like a pretty smooth surface or smooth transition. I don't see any dips, I don't see any bumps. But if I do this, you can see that there is going to be a little bit of a gap there. If I come in and I do this and go deviation, very small, 0.07. Many times when I'm modeling, especially if I'm going to do a 3D print out of plastic, I'm going to say that's good enough. If I'm doing automotive, that's got to be 0, no matter what. So the curvature combs help you to see if things aren't perfect. So it's all the way of build, evaluate, and refine. And that's why you want to be methodical in making sure you add your tangencies and your curvature between the two and add all the relationships. Okay, questions? No. Okay. So what we're going to do now is we're going to pause, take 15-minute break, so come back at 4:35. When you come back, I want you to open up the SolidWorks file I sent you because we're going to use that for our next step. Okay?
Hey Travis, I just want to let you know my computer crashed earlier.